All right, so I'm gonna just show a quick clip that you guys have up on the GitHub page, and I was hoping you could just kind of maybe tell people what we're looking at as we watch this, kind of do a sports cast, if you will, to help people just kind of get a bit of a visual element. So this is the AI did my groceries example. So Magnus, just tell us what we're seeing here.
Yeah, this was a friend of mine, and he's right now building a startup where he does grocery shopping for other people. And his problem was he always needed to do shopping on his own. So now he created a big prompt for browser use. It tells browser users, okay, go to this website and do the shopping for me with those elements. And now you can see, okay, browser use goes to the store and types in, for example, your oranges, and new products. And then it can click on the actual products and adds them to the chart. And with this, he can automate for his new startup, his shopping process, something which he would have done manually before.
And
this is just is a thing of one big prompt. You can see on the right, this is like a big prompt of maybe 100 lines of code. This is just natural language without studying computer science or anything or learning how to automate things. Just a prompt, and then it can get started.
And one thing I noticed watching this video is that it often draws, browser use draws what appear to be like boxes around text. Is that how the system parses discrete bits of information to figure out where like different options of like potato types would be listed? Or what am I seeing there with the squares, the colors, and the numbers?
Yeah. So we combine the actual HTML with the image of the current screen. And inside the HTML, like the DOM, all the elements where we have all the access. Okay, this is a button, those are the coordinates. This is the core part of our library. There we extract, okay, what are the elements where humans can interact with, like buttons, input fields. And in there, you have also access to the coordinates. So we can just take those coordinates and highlight them on the screen as bounding boxes. And then we can take a screenshot and can combine both and send it to an LLM.
Oh, okay, that's really interesting. So you're taking images of the website's elements and then sending that back to an LLM to essentially parse it. And then you can tell which thing to select, and then it can tell the cursor equivalent to actually click on the right thing. That is a lot of compute, Magnus. That feels like a relatively compute heavy. Am I wrong?
It depends how you define compute heavy. It's definitely much more than normal chatbots. And the main reason is that we have multiple steps. For example, let's say to fill out a form, you need 20 steps. And at every single step, one step, we take the current website and we send it to an LLM. And the LLM sends us back, click on button 5. And then the LLM sends us back, okay, go to this page. And then the LLM sends us back, okay, go and fill out this input field. And every single step, we send out the current website. It's around 8,000 tokens, let's say around 8,000 tokens together with the image. And the LLM gives us back the output. So it's around, I don't know, 1 to 3 cents per step, which you pay in token cost for GPT-4o. Now for newer models like Llama 4 or DeepSeek, we can drastically reduce those prices.